let's say, a neural net of a reasonable size is limited, right? Because most tasks that you want to solve require many steps of computation. You cannot reduce them to just a few steps. Many computational tasks are intrinsically serial, sequential, not parallel. So you may have to spend more time thinking about more complex functions than answering simple questions. So the better way of performing inference will be inference by optimization. So basically, you have an observation, you run it maybe through a few layers of a neural net, and then you have a cost function, which itself is a neural net that produces a scalar output, and what it's going to measure is the degree of compatibility or incompatibility between the input and a hypothesized output. Okay, so now the inference problem becomes one of optimization, searching for an output that minimizes the subjective function. I call this objective-driven AI, but really it's not a new concept at all. Like most probabilistic inference systems perform inference using optimization. I know there's quite a few people in the room who have worked on optimal control, so planning and optimal control, motion model predictive control, for example, produces output through optimization. I'll come back to that. Okay, so this idea is really not new, but we've forgotten about it. And I think we have to go back to it. We have to build systems whose architecture is such that they can perform inference by optimization. The output is not an output, it's a latent variable that you optimize with respect to. And this is really classical in traditional AI, if you want. The idea that you search for a solution among a space of possible solutions. That's very traditional. It's just kind of forgotten